Bismillahirrahmanirrahim. Assalamualaikum and uh, good night to you all. Okay, my name is Muhammad Abdul Ali. Today I want to present to you all about the my group project EET 203 microcontroller system design. My title of project is Smart Bag Conveyer. Okay, for now was our time. Okay, I want to introduce you all about the abstract. Okay, conveyor mechanical device used for transporting thing between different location of buildings. Typically, they take the form of a moving staircase consisting of a chain of single piece aluminium or stainless steel steps guided by a system of tracks in a continuous loop. Conveyor are commonly used in buildings where the movement of a large number of things such as bag and parcel are required, such as post hub, shopping centers, airports, transit system, and so on. Variation of the conveyor is the moving walkway which transports things horizontally. The speed of conveyors is not constant and is subjected to what thing that we want to transfer. Okay, for introduction, in this project we use PIC 16F877A microcontroller in controlling the movement and speed of the conveyor. Probably in the market no one has used this program yet. We try to apply what we have learned in this subject to the requirement of the latest technology. Okay, by using PC Lab, PIC Genius, dash PIC 16F877A simulator, the smart conveyor is tested to ensure that its movement meets the requirement of what we have set. This is to avoid any movement that is too fast and too slow on the conveyor. This will cause failure on the project. With this simulation, we can ensure that the movement meets our needs.
Okay, Assalamualaikum. So for my part, I will briefly explain about methodology. So for our OA83, we use a PIC 165878AA. The microcontroller is used in this experiment to control the conveyor speed movement system by using pulse wave modulation, as we know PWM, as a technique in which the digital pulse with the adjust to generate different average DC voltage to DC motor automatically based on the input voltage of the bag input sensor into the conveyor. Plus, the conveyor will move the capacity of the only 25% of its speed when no bags on it. So, when the conveyor receives the first bag, the sensor will give input to the PWM to increase speed, move the conveyor from no bag, for example 25% to 50% of its speed, and then to 75% and finally 95%. For the time period from one stage to another is in less than few seconds. Within a certain period of time, when the sensor does not receive any bag, the conveyor will return to moving at rate only 25%. So this system can save electricity and more efficiency. So this system is not set up to 100% to maintain the life of the motor and the conveyor. Using the PC Lab and PC Genius as a simulator, this smart conveyor is tested to ensure that it works accordance with the set motion of rules. So from system flow chart here, and then for result and discussion, The result was the design of this project. We are using PIC 16F8778A microcontroller, which has a total 40 pins and 30 pins for the inputs and outputs. C language is used as a program to communicate between microcontroller, input the output. Timer to capture or compare PWM. CCP model we use to capture by rising edge at CCP 1 con at input, where the pulse width modulation mode produce a PWM output by writing specific duty cycles to the PR2 register. The PR2 is the value loaded into the timer 2 register to generate an interpreter change on output speed. Analog to digital ADC converter are used in this program from data acquisition for the temperature sensor at the input, which is convert rising temperature as a voltage rising at the sensor interfacing to ADC value to control the fan speed at output. So, the oscillator frequency is set at 20 MHz, which is mainly convert DC from power supply to AC signal. The PWM frequency is set from this project at 5 kHz. The voltage reference VREF to calculate the outputs were set at 1 volt. Every rising temperature at the sensor was set as 1 degree Celsius, which is equal to 10 millivolt. The prescaler 16 selected to calculate the value that we needed into the program language. To validate the result, we using the PCIN lab units as a simulator. The simulation result will be demonstrated and explained through the recorded video. So that's all from me. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. Okay, today I will continue from my friend. I will present about a functionality demonstration for our project titled Smart Bag Conveyor. Okay, the first one is we define our program conveyor 2 at pin RC2, motion sensor at pin RB0, our indicator lamp for 50%, pin RD0 for 75%, pin RD1 for 95%, RD2 lastly for 25% at normal condition, RD7. It will show indicator for speed motor, our speed motor conveyor. The next is PIC initial, PWM initial, PWM step run, and lastly is equipment control normal. The three is our loop, and the lastly is our sub function. Okay, the next is we start our program. If motion sensor is equal to 0, that means our sensor is in active low. If 0, that means our sensor is detect back movement. Okay, when detect our motor will delay for 0.5 second before start the pulse width modulation. If don't have any detection at motion sensor, our motor will run back to the control normal, that is 25% of running motor. Okay, the next is our conveyor running. The first one is set at DC 0.5, that is our 50% of motor running. Then for each step it will delay for 0.5 second. That means our motor will not affect the change speed for the running. And then at our 0.75 is 75% of the motor. Then our motor will increase to the 95% of motor speed. Then if if the motion sensor not detect any bag, the motor will decrease the motor speed to 95% to 75%, then to 50%, and then back to normal. So that's mean when our sensor detect, it will running from to 25 to 15 to 70 to 75 and to 95%. For running 95%, it will running for 10 seconds if don't have any detection. If have detect of the bag, it will continues to 95%. If not detect, the program will decrease the motor speed to 75%, 50%, and our normal condition 75%. Okay, next we go to our program. We go to the simulation. Okay, first we need to debug our main project. Our project is successful, program is successful, then launching. We open the PSIM lab. Okay, now we can see our PSIM lab. We use PIC Genius and PIC 16F877A. Okay, then we open our oscilloscope to monitor the pulse frequency. And in the normal condition, our project we running, and the indicator lamp is at D7, pin D7, RD7. Okay, when the bag is detect, okay, now the bag is detect at a motion sensor. Then we can see our oscilloscope will show the increase of speed, and also at the LED will show the indicator lamp. And in this condition 95%, we can see that if have detection, it will keep running. And if not have any detection at motion sensor, it will running for 10 seconds, then it will decrease the speed motor to 75, 50%, and back to normal speed 25%. Okay, we need to wait for 10 seconds, and it will decrease the motor speed. As we can see, the temperature also will affect when the speed of motor. In this project, for oscilloscope, we use channel 2 to monitor, and we set the channel 2 at RC2 because RC2 is our motor speed bag conveyor. Okay, then okay, we can see the speed is decreased after 10 seconds. Okay, from that we can see that our project is successfully function based on what have we write the programming and what is our plan. Okay, for that we show you once more time. If the sensor is detect back on the conveyor, we can monitor the oscilloscope. The speed will increase 25%, 50%, 70%, and 95%. Okay, that's all for our simulation of program. Then lastly is as a conclusion, in this project we will be able to uh, use the PIC 16F877A microcontroller successfully when using the pulse width modulation program to control the speed of the conveyor. By using the PWN, we can control the movement of the conveyor at the desired level for 25%, 50%, 75%, and lastly 95%. The speed of this motor conveyor is deliberately not increased to the level 95% or 100% to maintain the lifespan of the motor because it will affect our board also, our programming, because it's connected with our temperature, the temperature. If it not too fast, may invite discomfort to the user. By running this project, we can also understand